Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0122 indicates a fault in the throttle position sensor A circuit, leading to low voltage readings. This issue is critical as the throttle position sensor TPS plays a vital role in engine management by informing the engine control module ECM about the throttle plate's position. The signal from the TPS helps regulate fuel injection and air intake, which significantly affects engine performance. In the Honda Odyssey models from 2011 to 2017, the TPS is located on the throttle body manifold assembly, easily identifiable by its wiring harness. Understanding the underlying cause of DTC P0122 is essential for opting for effective repairs, as failing to address it can lead to reduced engine efficiency and increased emissions. Proper diagnostic steps will help pinpoint the issue effectively, ensuring reliable vehicle operation. A Throttle Position Sensor A, TPSA, is an integral component of the vehicle's engine management system, primarily responsible for signaling the position of the throttle plate to the engine control module, ECM. This sensor is situated on the throttle body, which is part of the air intake system, and it plays a crucial role in regulating the air-fuel mixture according to the driver's acceleration input. By monitoring the position of the throttle, the TPSA influences various aspects of engine performance, including fuel efficiency and emission levels. A malfunction in this sensor can result in poor engine response, reduced power and acceleration, or even stalling under certain conditions. When the TPSA outputs a low voltage signal, it alerts the vehicle's diagnostic system, registering the P0122 trouble code. For accurate diagnosis and repair, the location and function of this component must be clearly understood. There are several possible causes for the P0122 code, each contributing to the low voltage reading from the throttle position sensor. First, poor electrical connections can create intermittent faults, leading to erratic sensor readings. This can be due to corrosion or loose wiring. Secondly, a faulty throttle position sensor itself might be the culprit. Sensors can degrade internally from heat or wear over time. Next, wiring issues, such as insulation damage or short circuits between the throttle body and the powertrain control module, PCM, can disrupt the signal. These issues need to be meticulously checked during the troubleshooting process to ensure the problem is accurately identified and resolved. Understanding each cause's implications is crucial for implementing effective corrections and restoring the vehicle's performance. The symptoms associated with DTC P0122 can significantly affect driving experience and vehicle operation. One of the most apparent indicators is engine performance issues, where the car may hesitate or feel sluggish during acceleration. This could be coupled with poor acceleration, making it difficult to respond effectively to the driver's input, posing a safety risk. Furthermore, the check engine light will likely illuminate on the dashboard, indicating a fault that needs immediate attention. These symptoms, while they can arise from various other issues, strongly correlate to problems with the throttle position sensor and underscore the necessity for thorough diagnostic procedures to pinpoint the exact fault. The first step in diagnosing DTC P0122 is to turn the ignition switch to the on second position without starting the engine. This allows for operational readiness of the vehicle's diagnostic systems. Once the ignition is on, you should clear any existing DTCs using the Honda Diagnostic System, HDS, a crucial tool that helps reset the system and allows for fresh data collection. Following this, the next crucial task is to check the Throttle Position Sensor A voltage via the HDS's data list feature. If the voltage reads about 0.3 volts or less, it confirms that the issue is present. If the voltage is above this threshold, it suggests an intermittent failure, hinting that the system might be functioning correctly at that moment, despite the recorded fault. This step sets the foundation for more in-depth troubleshooting, allowing technicians to further investigate if necessary. In the second troubleshooting step, after confirming low voltage from the throttle position sensor A, the next logical step is to check for any other pending or confirmed DTCs using HDS. Here, you are particularly looking for the presence of DTC P0222, which would signal issues with the secondary throttle sensor. If both P0122 and P0222 are indicated simultaneously, it suggests a more extensive problem in the throttle assembly or associated circuits. However, if only P0122 is present, you proceed to the next steps, focused specifically on addressing this trouble code. Identifying the status and combination of DTCs is critical, since it can streamline the diagnostic process and highlight broader systemic issues in the throttle control system. The third troubleshooting step involves preparing to isolate the throttle position sensor circuit by turning the ignition switch to the lock 0 position, completely powering down the vehicle's electrical system. Following this, you will disconnect the throttle body 6P connector to access the sensor wiring directly. Next, utilizing the HDS tool to jump the SCS line is a crucial action, as it allows the technician to bypass certain protective modes within the system, making the next tests possible. This step is essential for ensuring that the measurements taken in the subsequent steps are accurate and not affected by other systems that may engage while the vehicle is operational. These preparatory actions set the stage for deeper inspection of the sensor and its wiring, which is pivotal in diagnosing the root cause of the low voltage issue. In the fourth troubleshooting step, you must disconnect the PCM connector B, usually consisting of 49 pins. Disconnecting this component is vital, as it prevents any unintended influence from the ECM during testing. You then have to check for continuity between the throttle body 6P connector terminal number 6 and body ground. This test is crucial, as a lack of continuity indicates a wiring issue that can lead to the low voltage problem the P0122 code describes. If you find continuity, it points to the wiring being intact, suggesting a short exists elsewhere in the circuit between the throttle body and the powertrain control module, PCM. Understanding the nuances of wiring connections and their paths is key in rectifying the problem efficiently, as it follows a methodical approach to isolating issues within the vehicle's electrical system. Upon confirming continuity in the fourth step, the next action is to address any detected shorts in the wiring between the throttle body and PCM. This repair process may involve splicing or replacing sections of the wiring harness to ensure accurate electrical signals can transmit without interference or interruption. If the wiring looks visually intact but still presents faults during testing, it may mean there are hidden issues such as corrosion within connectors, which should also be examined. Post-repairs, it is essential to retest the system to ensure that the modifications had a positive effect on the overall functionality. Ensuring the throttle position sensor reads accurately after repairs confirms the corrective measures taken are valid. This procedural thoroughness ensures the car functionality is restored, keeping performance and safety in an optimal state. The final repair verification step serves to ensure that all repairs have successfully addressed the DTC P0122 issue. First, clear the DTCs using the HDS again to reset the vehicle's diagnostic memory. Following this, perform a test run of the vehicle under various conditions, including acceleration and steady cruising, to observe the integrity of the throttle response. During the test drive, The throttle position sensor's functionality should be monitored for proper voltage output. It is of utmost importance to check the system again for any triggered DTCs to ensure that the circuit is now functioning correctly. Completing this verification confirms that not only has the specific issue been resolved, but overall engine performance has also restored to optimal levels, ensuring reliability for future driving. Preventive maintenance is critical in avoiding future occurrences of issues like DTC P0122. Regular inspection of electrical connections and terminals is vital for detecting the early signs of corrosion or looseness that can lead to intermittent faults. An annual cleaning of the throttle body not only promotes its operation efficiency, but also supports longer sensor life by preventing debris buildup. Additionally, monitoring sensor readings and performing routine diagnostic checks can reveal underlying issues before they manifest as significant problems. By prioritizing these maintenance approaches, vehicle owners can extend the lifespan of their throttle position sensor and enhance overall vehicle performance, safeguarding against costly repairs down the line. In conclusion, understanding the DTC P0122 related to the throttle position sensor is essential for accurate diagnostics and repairs. Following structured troubleshooting steps ensures that technicians can isolate and address the underlying problems effectively. Recognizing the role of the throttle position sensor and its impact on engine performance emphasizes the necessity for accurate information and responsive action to rectify issues. Ultimately, the practice of regular maintenance cannot be overstated, as it minimizes the chances of similar faults emerging in the future. Implementing these practices creates a safer, more efficient driving experience in the 2011 to 2017 Honda Odyssey, delivering both reliability and performance. Please like and subscribe to the channel. See you next time.